Hi everybody, and welcome back to my EV3 programming series. In the fourth video, we're going to be finishing up with the color sensor, and lastly, we'll be plugging it into something called the variable block, so what your color sensor sees can be used within the rest of your program without having to reread the code every single time. Let's get started. Let's pick up where we left off, shall we? So let's delete these two, and we're going to be using the loop and the switches. So these function in much the same way as normally how we'd use the loops and switches. Instead, now we've basically unlocked the color sensor portion. So go to color sensor, reflected light intensity, and basically what this does is this loop will end as soon as we see something that's less than 50. If we wanted to change this to, for example, cut the loop as soon as we see black, we would do something like 15, much like the weight block, in fact, where we would use the color sensor and do this. It's essentially the same thing, and it ends the loop as soon as you see something. Let's plug this in, and for example, do 0.01. Basically, what this program would do is to jerk forward every, every 0.1 for 0.1 rotations, and then it would cut that as soon as you saw black. Now, this really isn't a functional version, and the reason why is because if we wrote a program like this on block would actually run forever. So this one block in reality runs for an infinite amount of time. It can be stopped by a wait block or like a stop command. But this one worked because it would just move forward indefinitely without actually searching for the black, and so we can't really use this right now. However, what we could do in order to replicate a program like the one we wrote before, which if I want to refresh your memory, is something like this. We could use the switch block, and we covered this, I'm pretty sure, in an earlier video, but if we actually change it to color sensor and then compare reflected light intensity, you see we have the exact same screen pop up as we do on the weight block. So swap this to 15, and this switch block is really important because how it works essentially is it takes the input from your front block, essentially the weight block, and it puts it into either a true or a false algorithm. What this does is it takes your color sensor value, sees is it below 15. If yes, then it will direct it to the top frame. If no, then it will direct it towards the bottom frame. So what we can do is we can add a note block to the top. So if we see a black line, we can make it play a sound. I'm going to make it play a C chord, or just the C note, for 2 seconds. And at the bottom, what we can do is we can use the brick buttons function. What you do is you drag it out, and then you can see under the color 1, you can change it to any color. I'll make it red. And lastly, we're going to drag a weight block because, again, how this block works is it's going to pulse so quickly that you won't be able to see it with your bare eyes. And we're going to just make it wait for 1 second. So essentially the light's going to turn on red for a second. If it doesn't see black, ergo if it sees white, and if it sees black, it's going to play a C note. Let's take a robot and let's run the program we just did. So if I put this over the black line, what it should do is it should make a beep sound. And it does exactly that. It makes the C beep sound that we set for 2 seconds. Now, if I put it over the white, what it shouldn't do is make a beep sound. But in reality, what it should do is it should light the brick button colors up red. And let's see what happens. Yep, it does exactly that. It does exactly what we programmed. So, interestingly, what if we put it on gray? It will flash red. You know why? Because we set it to 15. And I'm going to cover mid values right as I get back to the computer. But what it's seeing right now is approximately a value of 40, because I have the color sensor half on red and half on black and half on white, if you can see right there. It's right in the middle. And what that is the mid value, which is a combination essentially of the high value and low value, and then divided by 2. And if I put it slightly more on the black, you see there's a little bit of red. You can't see it from this angle, but it will still flash like that. However, if I put it slightly more over black, it will do the beep. So now let's go back to the computer and see what this mid value really is about and how we can use it. Now we're actually going to be moving on to the more complicated side of EV3 programming, which is the variable blocks. So these blocks are basically going to turn your robot into something that goes from something that you control more or less by your positioning, like where you put the robot on the table or where you put it on the field if you're doing FLL or something, to something that is truly autonomous and can make its way around pretty much anywhere you wish. However, this is a long process, and I'll be here to teach you the stuff necessary to get to that point. All of these start with something called a variable block. So if we drag it out, we see this interface. I'm going to zoom in a little bit, but basically this variable block isn't very complicated. At least it doesn't look very complicated. That's because it really isn't. If we click on here, we see there's read, and then all of these, and then there's write, and all of these. You're going to be using primarily, at least for this lesson, the numeric value. And most of the functions are more or less the same, although there are a little bit of conversion issues between them. Create these variables into our program. To do this, let's click on this area, and you'll see an add variable block. If you've messed around with a little bit, you might have seen some other names, but by default, it's add variable. Like, you shouldn't mess around with this because it will make random variables within your program. It's just going to be very confusing. So if we click on add variable, you'll see this interface which says new variable, and you can type in your variable name. So for this one, I'm going to type in low. And then I'm actually going to set up another variable, and we're going to call it high. And as you can see, our low actually shows up on this table. And I think you see where I'm going here, right? We have our low value and our high value. So previously we had it in a comments block, which is for our personal use. However, if we want this to be saved inside the actual robot, and we can have these values used in any program we want, we could do what I'm doing here. So we can plug in the low value as, let's just say 6 to be safe. And let's set the high value to 75 just to be safe. And essentially what I can do now is, I'll keep this comment block for now, but if you're doing this, you can feel free to delete this anytime you wish. So what if I want to read these programs? So we drag our variable block. I'm just going to have a new one just so you can follow along. Click on the write numeric, which is basically you can plug in the values and you go to read numeric. This essentially means that whatever number you plugged into, what I'm seeing here, low, will come out of this wire. So if I read this, I assume that it's going to be 6. Let's see how this works. For this test, you're going to have your robot connected. I realized that I didn't actually have it connected for the previous part, but that's completely fine. So make sure your robot is connected, Bluetooth, USB, either one works. And actually, before we start, we're going to have to add a wait block. You know why? Because these blocks take basically close to no time in order to process, and without the wait block, the program will end immediately. So let's go to break buttons, compare break buttons, and let's just wait for a center button press. And let's run this program. So how this should work is, at the beginning of the program, we write a 6 in the low, and then we'll now read the low value. So if you hover over it and then you drag down, you should see a 6 value right beside the wire. And that is exactly what we want. If you see that 6 value, or let's say you typed in a 5 and you see that 5 value, of course mine hasn't changed yet because it hasn't updated, or whatever value you plugged in here, if you see that exact value through here, it means that your thing works. And now we have a 6 value in this wire that's being outputted, and we can drag it into whichever one of these we want. Now let's do the same thing for the high value. Let's just drag across the read, which you can do by control click, and then read numeric, and we'll change it to high now. A good thing to keep in mind is that the low goes into the low, high goes into high, obviously. However, when you're copying over, it won't actually update it, which means that you're going to have to change it manually. A lot of programs get messed up by this, so always be sure to check which variable you're reading. Run the program again, and we'll see the 6 is still the same, and this should come out as 75. Yep, and it does. So that means our variables are set up properly. Let's see how we can actually use them in a program and how we can use it to save our color sensor values. Using these variables, what we can now do is, we'll move these out of the way first. What we can now do is called a calibrate. Well, obviously it's not the proper calibrate right now, but it's a very close thing to a calibrate that's used commonly by FLL teams in order to set up their robot to the table. What happens in FLL is the lighting conditions are usually different from table to table, from event to event, even from match to match. And what you do is you run the robot over a black part of the line, a black and white portion of the line, in order to see the highest and lowest values. What we're doing is a pseudo calibrate, in which you actually place it directly on a black line and you can test the low value, and then we can put it directly on a white portion and we'll see the high value. What you do is you go to the sensor portion and you drag a color sensor block. And remember that measure function that we had? Yeah, put that and then set it to reflected light intensity. This is very important because if you set it to color, it's going to range from 1 to 7, I'm pretty sure. But reflected light intensity, you'll actually get the value that you want. So, and then we'll put the low value here. So an interesting thing you can actually do with the input, or write numeric, is you can actually take the numeric input, which is the reflected light intensity, and plug it right into that block. What this will do is it will measure whatever the color sensor is seeing, and then it will put it into the low value. And now if we can add a read low, and we'll add a wait block at the end just to make sure we can actually read the value. We can see that whatever we have this over, which I'm going to be putting it over black, it's going to be around the 5 or 6 range, at least below 10 or 15. Let's run the program and see. So what we have here should be around 10, 5, 10-ish. And we see we have a 5, which is exactly within our low range as we've tested here. So this works perfectly. How do we record the high value as well as the low value in the same program? Well, we've already made our high variable. So what we can do is we can take 2 different measurements and we can save one into the low section and we save the one obviously over the white into the high section. So copy over essentially these 3 blocks, which is what I did here, and then change the low variable to the high variable and change this as well. So basically the first time you run the program over black, it's going to save it to the variable called low. And then after that's saved, you put it over a white surface, press the center brick button, and then you run the exact same thing as before, which takes the value and plugs it into a high variable, thereby saving the white value. Lastly, if we don't want this program to end, and we can see that values, we're just going to take this block over and drag it here as well. This allows us to look at both the low value from the wire and the high value from the wire just to check if we get accurate results. To test this program, let's run the program with your robot on a black surface or a black line. And then it should have saved the low value already, which it did for me. It's a 1, which is very low because it's a very dark area that I put it over, and without pressing the center button, put it over a white surface and press the center button once. And actually, it doesn't save the program. The reason why is because you held this down already. This takes no time to activate, and then it senses again that you've held the brake button down already. So what we can do is to combat this is it gives you 1 second timer to let go of the button before it reads again. Now let's try this again. Bring the robot back to your black area, run, and then we see the same value should pop up, which is 5, which is basically what's normal, and then press the button and release on a white surface. Now we see that it's actually stopped, and we can check the high value, which was 100, which is basically white value anyway, and both of our variables are set up properly. How do we use these variables in a way that we can use them throughout the program? Let's consider our old wait for black program. Remember how, if I quickly rewrite it again, remember how we actually had to plug in the value for a wait block and how annoying that was? Like, for example, here, we actually had to write less than 15. What if that value suddenly changed and our black our low value actually was at 20 for some reason. Maybe the room was extremely bright and the color sensor picked up pure black as 20. What would happen then? Well, obviously our program wouldn't stop anymore. So how we fix this is we can actually do something really cool, which is we can drag over the low value from before, because it's actually saved the variable within the program, and we drag the low value into the threshold value. And essentially what this does is we take our calibrate from the very beginning, our value that we took from the black, and we can run the program and it will stop automatically on that same value of black line. It's probably better if I show you this in real life, because this is going to be slightly more complicated than what we've did in the past. So download it and let's see what happens. Let's actually run the program that we programmed and see how it works. So if we play it, remember we want to start it on the black line. So put it directly on the center, and if we check there's no red seeping out, we run the program. And that saves the low value. Remember, we had to wait for a break button press in order to check the white value. Put it over the white value. I have a little bit of shadow, but that's okay. And we save that too. Now, if we press the center button, we're going to run the drive forward until you see a black line using the low value that we saved beforehand. And so play that, it's going to drive forward and stop immediately. That is the power of a calibrate. Now, if we make the room drastically lighter and we did the calibrate and run over again, it would do the exact same thing. So no matter which lighting it is, it's going to do the same thing. As you can see, our variable saved program is extremely useful. And our calibrate, of course, is good, but it can be improved on later. In the next episode, I'm going to show you how to actually make a proper calibrate, and hopefully, if we have time, and at least in the next 2 episodes, I'll teach you how to do a simple line follow using the color sensor values. Until next time, bye!